renal capsule that also covers the kidney. And it kind of pulls all the tissues together in a nice kidney shape. If we look at the kidney, it can be divided into two sections, just like the adrenal gland, having an adrenal cortex and an adrenal medulla. The kidney also has a renal cortex and a renal medulla. The renal cortex is actually just this thin layer right here, okay, quite small. And the medulla is everything inside there, okay? That includes triangular shaped structures and these passageways all the way to the center and all the blood vessels that you see in there, okay? Now, it is in the tissue of the renal cortex we're going to find the two other models, the renal corpuscle and the nephrons. That's where we're going to find them, in the renal cortex, okay? In the renal medulla, we have lots of tubes that actually carry the urine that has been created through filtration. As blood is filtered in the renal cortex, the urine that is pulled out passes through a whole bunch of tubes in the renal medulla, and we have this triangular structure. We can see we have many of them in the renal medulla. These triangular structures are called pyramids, renal pyramids, okay? And these are just collections of tubes, and they carry filtered urine down to the tip of the renal pyramid. The tip of this renal pyramid is called the papilla. Okay, the renal papilla. So blood is filtered in the cortex, urine is extracted by filtration. It goes through little tubes going down our renal pyramid to the papilla, the tip of the renal pyramid. The tip of the renal pyramid actually is where the urine is drained into another little passageway called a calyx. C-A-L-Y-X. Now, there's several calyces. There's major and minor calyces, and essentially that just is because some are smaller and they drain into larger ones. So we have calyces that carry the urine into a central area called the renal pelvis. Renal pelvis. This renal pelvis right here collects the urine, and then the urine drains down into this tube, the ureter. So structures to identify are renal cortex, renal pyramid, renal papilla, renal calyces, renal pyramid, and we can also see our renal artery and our renal vein as well. Okay. Oh, and we have our renal capsule. Okay. Now there is a section in between these renal pyramids. There is some tissue. This tissue is called a renal column, and it's just an extension of the renal cortex. The renal cortex is just this narrow band, but every once in a while it dips down in between the pyramids, like this, dipping in between. And the part where it goes down in between the pyramids is called a renal column. Okay? All right. But the important structures are going to be in the medulla so far in this model, renal pyramid, papilla, renal calyces, renal pelvis, and ureter. Now, the renal cortex contains two important structures. The structure that actually filters the urine, which is the renal corpuscle, and we have a separate model for that, and a structure that actually also helps to filter that urine, or at least condense it and form it, and that is the nephron. That's also found in the renal cortex, and we have a separate model for both of those structures. The image that is provided us for our packet is a model that I don't actually use. So I'm going to show you the model that I use. I don't find this model terribly helpful because I like the model I use because it color differentiates the various tubules that we look at. Here we're looking at a complete nephron. That's what we're looking at. The nephron consists of this circular structure, which is the renal corpuscle, plus a whole bunch of tubules. Okay? And we also have tiny, tiny blood vessels. We have actually arterial and some capillary. So we're going to have to identify all of these structures. So I'll leave this up here, but the actual model that I use, I'm sure we have an image of it on one of the PowerPoints I provide. Maybe on the practical study PowerPoint might be on there, to identify the same structure on the model that I prefer. Okay. Now, what you're going to see is that blood is going to bring, vessels are going to bring blood to the renal corpuscle. We start out with essentially bringing blood into the kidney. We have our renal artery. That renal artery is going to branch into smaller and smaller vessels until we get this tiny arteriole that actually carries blood directly into the renal corpuscle. This is called the afferent arteriole. The afferent arteriole is going to, again, carry the blood into the renal corpuscle. Inside the renal corpuscle, which we have a tangle of capillaries, that's called the glomerulus. And then the outside of the renal corpuscle is a layer of simple squamous epithelium. That's what this white outermost circle is. Simple squamous epithelium, and we call that Bowman's capsule, or the glomerular capsule. The blood that enters the glomerulus is filtered. The material, waste products that are filtered out, leave the glomerulus at the back through a small tubule. The blood in the glomerulus enters through the afferent arteriole, and it exits the glomerulus through another arteriole called the efferent arteriole, which has not been pointed out here. Has it? Up there. Oh, there it is. Okay. Efferent arteriole. That exits. E for exit. That's how I think about it. E for exit. And that carries the blood out of the glomerulus in the renal corpuscle. This blood will then, through the efferent arteriole, go into small capillary branches. Those capillary branches actually end up forming a network that surrounds the tubules of the nephron. And we call these peritubular capillaries. Okay, peritubular capillaries. And note that the blood is still rich in oxygen. We are not delivering oxygen when we go into the renal corpuscle. And it isn't until those peritubular capillaries actually are leaving the nephron that they actually become veins. Peritubular veins leave and will exit, carry blood away from the kidney. Okay, so essentially this is all oxygen-rich blood that's being filtered. Okay. Now, what happens with the tubules? Urine that is filtered from the glomerulus will exit the renal corpuscle through a small tubule, and that tubule is called the proximal convoluted tubule. Okay, that's the tubule that exits the glomerulus. Okay, it then twists and turns and winds, and that proximal convoluted tubule will then dip down into a loop that descends all the way into the medulla of the kidney. Up here is cortex, down here is medulla. So this section of the nephron that dips down is called the loop of Henle. And we have from the proximal convoluted tubule the descending loop of Henle, and then it comes up, back, upward into the cortex as the ascending loop of Henle. And then this tubule again becomes convoluted, is known as the distal convoluted tubule. It winds and then it ends up going, after winding around, twisting and turning, it ends up joining this very straight tubule right here, which is called the collecting duct. Okay? As the filtrate passes through the proximal convoluted tubule, the descending limb of the loop of Henle, the ascending limb of the loop of Henle, the distal convoluted tubule, the material inside of those tubules is being concentrated. Okay? And whatever is left over is actually going to be the urine. It goes into the collecting duct. The collecting duct is going to be actually part of the renal pyramid. And then from the pyramid to the calyces, to the renal pelvis, and then down the ureter to the urinary bladder. Okay? So again, we're going to go over all of that in our lecture, but in terms of identifying structures, these are the structures we have to identify. Now, the model that I like to use, and I'm just going to see if I can find it on our, see if we have it on our